Have you ever looked up at the night sky and wondered if those twinkling lights are more than just distant balls of gas? Some scientists are beginning to ask, could stars in some sense be alive? They see cosmic processes that echo the cycles of life, birth, activity, and death. This idea challenges our basic assumptions about life and where it might exist. Our sun, for example, is a colossal nuclear furnace, mostly hydrogen and helium. Deep in its core, hydrogen atoms fuse to create helium, releasing immense energy. This energy travels across space, warming our world and powering life. Every second, the sun converts millions of tons of hydrogen into helium, a cosmic alchemy ongoing for billions of years. Stars change and evolve over time, responding to internal and external forces. This slow evolution draws parallels to living organisms. When we ask if a star is alive, we're not suggesting it has thoughts or feelings. Instead, we use the concept of life as a metaphor to understand these complex systems. We recognize patterns, creation, growth, interaction, decay, mirroring those in living things. Exploring this idea opens our minds to a new view of the cosmos, not as a cold machine but as a dynamic, evolving entity. The universe is more complex and interconnected than we ever dreamed. By seeing these patterns, we find new ways to understand our place in the cosmos. The story of stars is a story of transformation, echoing the cycles of life on Earth. Perhaps in its own way, the universe is more alive than we imagined. To understand a star's life, we must understand its engine: nuclear fusion. In a star's core, gravity crushes hydrogen atoms together, fusing them into helium and releasing energy. This energy pushes outward, balancing gravity's inward pull, a cosmic balancing act that keeps a star stable for billions of years. Think of it as a celestial metabolism. A star consumes hydrogen fuel, digests it through fusion and radiates energy. This process defines a star's active life. Without fusion, a star would be a cold, dark ball of gas. Fusion not only creates energy, but also forges new elements. The universe began with mostly hydrogen and helium. Every other element, the carbon in our cells, the iron in our blood, was made in stars. Stars are the universe's element factories, enriching the cosmos as they age. Stellar nucleosynthesis is fundamental to planets and life as we know it. We are, quite literally, made of stardust. The atoms in our bodies were once part of ancient stars. The life of a star is a story of transformation, creation, and cosmic connection. Understanding what makes a star shine reveals our own origins in the universe. Every star begins in a vast cloud of gas and dust, a nebula, the universe's stellar nursery. Sometimes a disturbance triggers a collapse and a dense clump forms, pulling in more material. This protostar grows, heating up as it gathers mass. It glows from the heat of collapse, not yet from fusion. When the core reaches about 10 million degrees, nuclear fusion ignites. The star is born. A powerful stellar wind blows away the remaining gas and dust, revealing the newborn star. The star enters the main sequence, achieving a stable balance between gravity and fusion. This process mirrors the birth of living organisms, raw materials, a trigger, growth, and emergence as an independent entity. The birth of a star marks the start of a new chapter in the cosmic story. Each new star becomes a source of energy and matter, shaping its corner of the galaxy. The cycle of star birth is a fundamental process, echoing the beginnings of life. In the universe, every new star is a spark of possibility. Like all living things, stars are born and must eventually die. A star's fate depends on its mass. Smaller stars, like our sun, live long, steady lives, fusing hydrogen into helium for billions of years. When hydrogen runs out, the core collapses, the outer layers expand, and the star becomes a red giant. Helium fuses into carbon and oxygen, but eventually, even that fuel is exhausted. The outer layers drift away as a planetary nebula, leaving behind a dense white dwarf. The white dwarf cools over trillions of years, fading into darkness. Massive stars live fast and die young, fusing heavier elements up to iron. When fusion stops, the core collapses, triggering a supernova explosion. The supernova creates elements heavier than iron and blasts them into space. This material seeds new stars and planets, continuing the cosmic cycle. The remnant becomes a neutron star, or if massive enough, a black hole. A star's death is not an end but a transformation, returning matter to the universe. The life and death of stars drive the renewal and evolution of the cosmos. Each stellar ending is a new beginning for the universe. The cycle of stars is the engine of cosmic change. Stars are active participants in the cosmic ecosystem, shaping their surroundings in profound ways. Their gravity holds planets in orbit, creating stable systems where worlds can form and evolve. The star's energy defines the habitable zone, the region where liquid water might exist. This energy drives climate, weather, and photosynthesis, making life possible. But stars also unleash powerful stellar winds and flares, which can threaten planetary atmospheres. A planet's ability to survive often depends on its magnetic field, shielding it from stellar onslaught. Beyond their own systems, stars collectively shape galaxies, their light and gravity influencing cosmic structure. Supernovae enrich the interstellar medium, triggering new generations of stars and planets. This is a galactic-scale recycling program. The death of one generation provides the building blocks for the next. Stars are the primary agents of change in the universe. Their influence extends far beyond their own light. Through their life cycles, stars drive the cosmic story forward. When we ask if a star is alive, we run into the limits of our Earth-based definition of life. Biologists look for cells, metabolism, growth, response to environment, reproduction, and evolution. Stars aren't made of cells, they're plasma, not biology, but they do grow, accumulating mass as protostars. They have a kind of metabolism, consuming hydrogen and releasing energy through fusion. Stars respond to their environment, adjusting to internal and external changes. Reproduction is more complex. A star doesn't make a copy of itself, but its death seeds the next generation. The biggest difference is heredity and evolution. Life on Earth evolves through DNA and natural selection. Stars follow predictable paths, set by mass and composition. There's no random variation or genetic inheritance in stars. Stellar evolution is governed by physics, not biology. The analogy between stars and life is compelling, but it breaks down at the details. Still, the parallels, growth, metabolism, response, legacy, are striking. Stars may not be alive by our standards, but their life cycles echo the rhythms of living things. Rethinking our definitions helps us see the universe in new ways. The story of stars challenges us to expand our understanding of life itself. Let's explore the parallel between stars and metabolism. On Earth, metabolism is the flow of matter and energy that keeps organisms alive. A star, too, is a system far from equilibrium, maintaining its structure against the cold of space. Its food is hydrogen. Its digestion is nuclear fusion. The energy released pushes outward, balancing gravity and keeping the star stable. Stars produce waste. Helium ash builds up in the core, forcing adaptation as the star ages. This cycle of consuming fuel, producing waste, and adapting mirrors biological metabolism. The star's light is its exhalation, releasing energy into the universe. While the chemistry is different, the principle is the same. A star is a complex, organized system processing fuel and releasing energy. Stars are cosmic-scale metabolic systems. Their life cycles echo the fundamental processes of life. Reproduction is central to life, but stars don't create offspring in the usual sense. Instead, they leave a legacy at a cosmic scale. The first stars, formed from hydrogen and helium, lived fast and died in supernovae. These explosions seeded the cosmos with heavier elements, carbon, oxygen, iron. New stars formed from these enriched clouds, leading to planets and eventually, life. Our Sun and Earth are products of this stellar legacy. The atoms in our bodies were forged in ancient stars. This cycle of birth, death, and rebirth is a form of galactic reproduction. Each generation of stars adds complexity to the universe. Stars don't reproduce biologically, but their life cycles make future creation possible. We are the descendants of stars, inheriting their stardust. The universe's creativity unfolds through the legacy of stars. Are stars alive? By strict biological standards, no. They lack cells, DNA, and natural selection. But maybe our definition is too narrow, too earthbound. Stars are complex, organized, and creative in their own way. Thinking of stars as living systems expands our imagination and understanding. Life on Earth is carbon-based, but could there be other forms? Plasma, nuclear, cosmic? This idea blurs the line between living and non-living, challenging our assumptions. Seeing stars as part of a cosmic life cycle connects us to the universe. We are stardust, animated for a brief moment to contemplate our origins. The universe is a story of transformation, birth, and renewal. Studying stars teaches us about our own beginnings. The cosmos is full of mysteries, and the next discovery may redefine life itself. The quest for knowledge is a journey, not a destination, and the stars will always beckon us to wonder.